So the basic 8 you're going to learn and use for this particular lesson are these in the box. So these you want to memorize as best you can because you're going to use them a lot. So we're going to say that cosecant theta is 1 over sine theta. Tangent theta is sine theta over cosine theta. Secant theta is 1 over cosine theta. Cotangent theta is cosine theta over sine theta. And bring this down just a little bit. Cotangent theta is 1 over tangent theta. Okay, so we've got two different things we can use with cotangent theta, right? All right, and then our basic ones here, unmanipulated, but knowing that we could solve them for the others. So sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. Okay. All right, so now we're going to use these identities to simplify some expressions. Okay. All right. So here are our first two. And we want this to be one single trig function or number. And when they say single trig function, it could be like sine squared theta would be acceptable, but we don't want any other of the trig functions in there. Okay, so this is where we have to get creative because there's not just one way to do these. I tend to try and simplify the things not sine or cosine when I start. So for this sine theta, I can convert that. I know that that's equal to 1 over cosecant, but cosecant, I don't know how that relates to cotangent. But I do know that cotangent theta in relationship with sine theta, we have the identity that says cotangent theta is equal to cosine theta over sine theta. So I can replace cotangent with cosine over sine. Okay, now, and this means to multiply, so I've still got the sine theta. All right, so I know when I multiply fractions, right, I can also divide out like factors. So sine theta divided by sine theta is 1, and I am left with cosine theta, which is one trig identity. So I've accomplished what they asked me to do here. Okay, all right, so sine squared theta, I was thinking, well, I could write that as sine theta, right, times sine theta over cosine theta. Because I was thinking that might help because now, I could replace that with tangent or something. I don't know. I'm just kind of looking at it as I don't know what exactly I want to do here, but I know cosecant theta, the only identity I have for cosecant theta is that it's 1 over sine theta. Okay. So here we go. Since we're multiplying, again, I can divide out like factors, so that's 1. And so then I have simply sine theta over cosine theta. And I have the identity that says sine theta over cosine theta is tangent theta. So there's my 1. Okay. All right, let's look at some more. Okay, so we have cosecant squared x times 1 minus cosecant squared x. All right, so then I'm thinking, okay, that's probably those 3 identities over on the side, the last ones we wrote down. The sine squared theta plus cosine squared theta equals 1 and all that. So I'm thinking, okay, that's probably something I want to use. So I thought, well, I know that 1 minus cosine squared x is equal to sine squared. So I could simplify that pretty easily. Okay, and then cosecant, again, I have a couple things with cosecant, but I was thinking, well, that'd be the same thing as 1 over sine squared x, right? Since we're multiplying, and then I have the like terms. or the like factors, which would divide out, and so I'm left with 1. Hey, that wasn't horrible. Okay, so I'm looking here, and I'm like, what can I do? What can I do? Well, sine x, I could write it as 1 over cosecant, but then I'd have 2 of those. So I thought, well, cosecant is 1 over sine, so that might be a little bit easier. So I rewrote that as 1 over sine x. Okay, so now all I have is sine x. All right. So then I was like, okay, what can I do with that? Well, if I got rid of the parentheses, right, by distribution, that might help. So let's try that. So I get sine x over sine x, and then minus, and then sine x times sine x is sine squared x, which is sine divided by sine would be 1. Oh, and that's one of those identities I wrote on the other page, right? 1 minus sine squared x is cosine squared x. Cool beans, got my 1. All right, so I'm done. Okay, so I know as you're looking at these, you're like, oh, that's a lot of thinking, and it is. So you're going to have to decide, which way to go. And I'll tell you, I'm making it look easy, but I worked these out before I made this video, so I would have one way to show you, because when I started, I have a lot of scribbles and ideas that I was having, that I could have gone that way, but it wasn't working very well. So just know that you may start off with one way and end up, kind of going around the other way, and you're just going to work on replacing. As you work with these, you'll figure out kind of the patterns, and you'll start to see, oh, this usually works best, or those sorts of things. Okay, so for instance, here with cotangent squared theta, my first thought was, well, that's cosine squared theta over sine squared theta. And then I was like, well, that's going to be messy, because then I'm going to have a fraction over another fraction, and 1 plus cosecant theta, that would be 1 over sine theta. And then I was like, ooh, that's a lot of mess. So then I started saying, okay, what else have I got for cotangent squared theta? And I remember the one that said it would be cosecant squared theta minus 1. Okay, and then I still have the 1 plus cosecant theta. So I'm thinking I'm going to try and get everything in terms of cosecant theta, right? And then, so here, sine theta is 1 over cosecant theta times cosecant theta. Well, that's simply 1. So now I have this is plus 1. Okay. So I'm looking at this and I'm like, what else have I got? Okay. Well, remember on the front page it said that identity a squared minus b squared equals a plus b times a minus b. Well, here's my cosecant would be my a, 1 would be my b, so I could rewrite this as cosecant theta plus 1. And cosecant theta minus 1 all over 1 plus cosecant theta. And then I still have my plus 1 out here. Okay, so I was like, well, what was that about? How did that help me, right? Oh, look, cosecant theta plus 1 would be the same thing as 1 plus cosecant theta, right? Because addition's commutative. So that would divide out, and now I have cosecant theta minus 1, and then plus 1. Well, negative 1 plus 1 is 0, and now I have cosecant theta. Okay, that one was a little tricky, I admit. All right, so having to pull on those other algebra skills as well as our trig functions and trig identities. All right, so I'm looking here and I'm like, that looks really weird. Okay, but then I looked, I said, oh, those look a lot alike, except this one's cosecant and this one's sine. So if I multiplied these two together, I should get, right, back to that a squared minus b squared. So I tried it out. I'm a hard sell. Sometimes I went ahead and multiplied the whole thing together to show myself that, yes, that was indeed what was going to happen. So I went ahead and did my distribution, and I got sine squared theta plus sine theta minus sine theta, and then minus 1. And of course, that's 0, right? Sine theta minus sine theta. So I did indeed get sine squared theta minus 1. Okay, so now I've got one term, but I've got this other number, so that's not exactly what they wanted me to have, right? So then I was like, well, sine squared theta minus 1, I don't have anything that says that. I have the one that says cosine squared theta, right, is equal to 1 minus sine squared theta. And that's close, but, you know, we can't do close. We have to actually come up with something. So then I was like, okay, well, if I got, if I worked with this just a little bit, right, really the signs are just changed because one is positive and one is negative and everything. So I thought, if I multiply everything by -1, right, which is a legal move in algebra, right? As long as we multiply everything by the same thing, I would have negative cosine squared theta equals -1 plus sine squared theta. And since addition's commutative, that would be the same thing. So I could replace all of this simply with negative cosine squared theta. All right. That brings us to the end of our notes. I would like you to work on assignment 4-1, which is using these 8 trig identities to simplify just as we've done with these last examples.